Hey everyone, it's Miss Joyce. Today we'll be dividing 3-digit by 2-digit whole numbers using the standard algorithm. Let's start with 320 divided by 10. First, let's set up our problem. On the inside of our division symbol, we're going to put the dividend, which is 320. On the outside, we're going to put the divisor, which is 10. We're going to be using the standard algorithm today, so let's list out our multiples of our divisor 10. The multiples of 10 are 10, 20, 30, 40, 50, 60, 70, 80, and 90. This will be the first 9 multiples of 10. We're going to use this to help us divide. Let's start by dividing our biggest place value first, which is the hundreds place. So we're asking ourselves, what can we multiply by 10 to get closest to 3 without going over? Well, if we look at our first multiple of 10, we know that 10 times 1 is 10. That's already too big. We don't have 10 hundreds to share. We only have 3. So that means we don't have enough hundreds to share evenly between 10 groups. So we're going to give each group 0 hundreds. So we're going to place a 0 up here in the hundreds place. We know that since we're giving each group 0 hundreds, that we are sharing a total of 0 hundreds. Another way we can get this 0 is by multiplying 0 times 10, which is 0. So we have 3 hundreds, we're sharing 0 of them. That means we have 3 hundreds left to share. We can rewrite these 3 hundreds as tens. So we're going to bring down the next digit, the 2, which means that we have 32 tens to share. So let's look at our multiples of 10 to see which multiple gets us closest to 32 without going over. We can see that our third multiple of 10 gets us closest to 32. So 30 is as close as we can get. 30 is the third multiple of 10, so that means each group is going to be getting 3 tens. So in the tens place, we're going to place a 3. If we're giving each group 3 tens, and there are 10 groups, we'll be sharing a total of 30 tens. We can also get this 30 by multiplying 3 tens per group times 10 groups gets us 30. So we had 32 tens to share. We shared 30 of them. We have 2 left. We can now go ahead and bring down the next digit in the ones place, showing that we now have 20 ones. So we're going to look at our multiples of 10 to see which multiple gets us closest to 20 without going over. And we can see that the second multiple gets us as closest to 20. It gets us exactly there. So 20 is the second multiple of 10. So that means we can give each group 2 ones. And we can represent that 2 up here. So we're giving each group 2 ones. So that means we're sharing a total of 20 ones. We can also get this 20 we're subtracting by multiplying 2 times 10, which is 20. So we have 20 ones to share. We're going to share all 20 of them. That means we have 0 left to share. So since there's no other digits to bring down, we are done dividing, and our quotient or answer is 32. So each group is getting 32. Let's try another problem. Here we have 235 divided by 11. First, we're going to set up our problem by placing 235 in the inside of our symbol and 11 on the outside. We're going to list our multiples of 11 since 11 is our divisor. So we have 11, 22, 33, 44, 55, 66, 77, 88, and 99. We're going to use this to help us divide. Let's first look at the biggest place value, which is the hundreds place in our dividend. We're asking ourselves, what can we multiply by 11 to get closest to 2 without going over? Well, if we look at our multiples, we can see that first multiple is already too big. We don't have 11 hundreds to share. We only have 2 of them. So that means we cannot give any group any hundreds yet. So we are going to place a 0 up here in the hundreds place, showing we're giving each group 0 hundreds. If we're giving each group 0 hundreds, That means we're sharing a total of 0 hundreds. So we'll be subtracting 0 to see how many hundreds are left. We can also get this 0 by multiplying 0 times 11, which is 0. So we have 2 hundreds to share. We're sharing 0 of them, so we have 2 hundreds left. Let's go ahead and bring down the next digit, showing that we now have 23 tens. So we can look at our multiples to see which multiple gets us closest to 23 without going over. We can see that 22, which is our second multiple, gets us closest to 23 without going over. So that means we're going to be giving each group 2 tens. So we're going to place a 2 up here. If we give each group 2 tens, and there are 11 groups, we're going to be sharing a total of 22 tens. Another way we can get this 22 that we're subtracting is by multiplying 2 tens times 11 groups to get us 22 tens shared all together. So we have 23 tens. We're sharing 22 tens. That means we have 1 10 left over. We can now rewrite this as ones by bringing down the next digit. So we have 15 ones to share. We're going to look at our multiples to see which multiple gets us closest to 15 without going over, and that would be the first multiple of 11. So we can go ahead and give each group 1. So we're placing a 1 up here in the ones place. This shows that we're giving each group 1. There are 11 groups, so we're sharing a total of 11 ones. We can also get this 11 that we're subtracting by multiplying 1 per group times 11 groups gets us 11 ones shared. So we had 15 ones. We're sharing 11 of them, so we have 4 ones left over. Since there are no other digits to bring down, this 4 is going to be our remainder. So our answer is 21 remainder 4. Let's try one more problem. Here we have 318 divided by 15. We're first going to go ahead and place the dividend on the inside of our division symbol. So we'll place 318 on the inside, and we'll place 15 on the outside. We're going to list our multiples of 15 since 15 is our divisor. So we have 15, 30, 45, 60, 75, 90, 105, 120, and 135. We're getting into some big numbers here. So if you just want to list out the first 5 multiples of 15, you can. And then if you need more later, you can always continue your table. So let's start by sharing the biggest place value, which is the hundreds place in this number. We have 3 hundreds. So we're going to look at our multiples of 15 to see which number gets us closest to 3 without going over. Well, we can see that first multiple of 15 is 15. That's already too big. So we can't give each group 100 because we don't have enough. So we're going to instead give each group 0 hundreds. So we'll place a 0 in the hundreds place. So if we give each group 0 hundreds, that means we're sharing a total of 0 hundreds. We can also get the 0 that we're subtracting by multiplying 0 times 15 to get 0. So if we have 3 hundreds, we're sharing 0 of them. That means we still have 3 hundreds left over. We can rewrite this 3 hundreds as tens by bringing down the next digit. So we have 31 tens. Let's look at our multiples of 15 to see which number gets us closest to 31 without going over. We can see that our second multiple gets us closest to 31. 2 times 15 is 30. So that means we can share a total of 30 tens by giving each group 2 tens. So in the tens place, we're placing a 2. So each group is getting 2 tens. If we give each group 2 tens and there are 15 groups, we're sharing a total of 30 tens. So we have 31 tens to share. We're going to share a total of 30. We have 1 10 left over. We can rewrite this 10 but in ones by bringing down the next digit. So we have the 18 ones. we're going to look at our multiples of 15 to see which gives us closest to 18 without going over. We can see that first multiple of 15 gets us closest to 18 without going over. So that means we're going to give each group 1, 1, and we'll share a total of 15 between all the groups. So we're going to put a 1 up in the ones place here, showing we're giving each group 1, 1. If we have 1, 1 in each group, and there are 15 groups, we're sharing a total of 15 ones. If we subtract the 18 ones we have, we're sharing 15 of them. That means we have 3 ones left over. So there are no other numbers to bring down. The 3 is our remainder. That means our quotient is 21 remainder 3.